So first this year, we released a very first version of a bridge for ROSCon because still a lot of users are using ROSCon. And this bridge supports Noetic, and it acts either as a ROS master. It's per configuration. You can start this bridge or this Zenoh plugin for a router as a ROS master, and all your ROS1 node will connect to this master and communicate peer-to-peer with each other. But at the same time, they will bridge to Zenoh, and then you can have the use case that we have at the bottom, which is integration with Zenoh, with all the plugins that you can benefit from Zenoh, or directly with Zenoh applications, with Zenoh Pico applications, and so on and so forth. Or you can also perform bridge-to-bridge connectivity, so crossing NATs, crossing WAN, going to a router in the cloud, or whatever deployment you want in a complex deployment between various robots, all in ROS1. It can replace ROS master, or it can connect to a ROS master already deployed in your robot. So as you wish. And last year, we already had a lot of success with the DDS bridge for Zenoh. A lot of users are using it, as you have seen already in previous presentations. But still, we felt that we can do better with a more tight integration with ROS2. Now, that's what we did a few months ago with a new bridge for ROS2, dedicated to ROS2, which provide better integration with the ROS graph. So it means also the ROS tooling is working far better. You can see if you have two bridges interconnected together, you can remotely see all the topics, all the services and actions from a remote robot through the Zenoh bridges. And you can also have RVs working very well across Wi-Fi, across the internet, and so on and so forth. The services and actions are mapped now on Zenoh queryable, which makes those far more easier to call from any Zenoh application. Just do a get operation, and you can call a service, you can call an action, providing you give the correct payload encoded in CDR as usual. And we also improved a lot the discovery information between the bridges with regard to the previous forwarding mode in the DDS bridge. This mechanism leverage the liveliness tokens that are now also used in RMW Zeno, which is work in progress. And most of us, an interesting feature is configuration of ROS namespace directly on the bridge, meaning that you can keep your robot without any namespace working locally without any namespace inside your robot, and the bridge on the fly, exposing all the services, topics, and action outside to Zenoh will prepend the ROS name you configured directly on the bridge, meaning there is no longer need to configure each node in your robot. And what's next is, of course, the RMW Zeno that Franco and Yadu introduced just a few minutes ago. And that's work in progress. We are actively supporting this, providing some extension of feature in Zeno C. The target release will be in May, but we hope to have the possibility to test it and to make you test it sooner than May. And it's already reusing some ideas that we implemented in the Zeno plugin for ROS2, like the liveliness tokens for grass discovery and the queryable for services and actions, and also the publication cache and querying subscriber for transient local, and so on and so forth. And for this year, our goal will be, of course, to follow and support this RMW Zeno, but also to adapt the bridge that we have to also work seamlessly with RMW Zeno. So in this sense, you will be able to perform integration between an existing system using RMW DDS and a new system using RMW Zeno. And the bridge will make sure that all the RMW DDS node will appear as RMW Zeno nodes in the other system. So you may have a seamless integration. So demo time. Here is what we can do with the two robots we have here. So
start the camera.
Yeah. So we have two Turtlebot 4 nodes, robots, which are just here. On those robots, I will deploy the bridges, each one configured with a different namespace, bot 1 for the first one, bot 2 for the second one. And on my laptop, I will start a third bridge with / as namespace. It means that on the wire all the topics coming from bot 1 will be prefixed by bot 1. And the bridge here will still expose those as /bot1 with a bot1 namespace on ROS2 environment on my laptop. So I can distinguish the two robots in two different RVs on my single laptop. And there is no mix of different topics, services, and action between the two robots. At the same time, I still can have a fleet manager application, not as a ROS node, but as a pure Zeno application that will just publish some twist message on the Zeno topic, which are here used by the two bridges. So with this fleet manager, I'm able to drive the two robots. So let's see how this works. So here I'm connected to, I will remove this. Here I'm connected to the two robots. So at first I will start a bridge on each. So we can see already that in less than 1 second, this bridge discovered everything that is running on DDS on the robot, all the services, actions, publication, and so on. Here I'm starting a second bridge on the second robot, and you can see in 1 second it discovered everything. So now here I'm on my laptop, and I will start the bridge without any namespace. What we can see here, you can see we have a mix of various declaration, announcement of different subscription services, actions by the two robots. And that occurs also in less than 1 second. So now in here, for instance, I can do a ROS2 topic list. And I get all the topics prefixed with bot 2 and with bot 1. And you can see there is a lot of topics, a lot of various topics by the two robots. I can also list the services, for instance. So you can see we have the service for bot 2 and the service for bot 1. So now with this bridge, everything is working seamlessly with regard to ROS behavior. So now let's start our RVs. I'm starting a first RVs connected to bot 1. And we can see already the LiDAR, which is showing up here.
And yeah, and usually it's not that fast.
Usually, yes, if you are plain DDS for ROS2, it's not that fast. You need to wait several seconds or several tenths of seconds to get
it was instantaneous there, yeah.
But now here we get the second robot LiDAR working. The camera are not on yet because the robots are on dock. But let's now move the two robots with this Python script. So here I just have the Python script. That's the exact Zeno Python teleop script we provide in a repository Zeno demos. So if you want to use it. So now it's connected to the two robots, and let's go. Whoa. And you can see all the reactivity. We have the feedback from the camera. And still I can choose to drive only one. For instance, here, if I'm starting the standard teleop from ROS2 and just using /bot1 as a namespace, now I can drive only the bot number 1. And here it's based with the teleop from ROS2. It's not a Zeno application, while the fleet manager was just the Zeno Python script. So that's what already we can do with this bridge. You can see a very smooth integration of ROS2 with Zeno. And now the next step is from Gabriele that will show what we have next with regard to the Zeta platform.